going to look at a bunch of different sections, but the first thing we're going to look at is 1.5, which is solving equations and inequalities. So first of all, what is an equation? Well, an equation is where two expressions or more are equal. So what distinguishes an expression from an equation is the fact that an equation has an equal sign. So I'm going to solve, and I bet you could pause the video and solve it just as fast, but that's okay. I would distribute, and then combine like terms, moving this, combine any like terms if there were any, and then I'm going to move this r to the other side. I'm solving for r. R is 1. It's always a good habit, a mathematical habit, to take that value and plug back in to make sure it really does come out the same. Number 2 is a little trickier because I'm solving for x, but now I'm going to do the same first step. A times x minus 8 equal to x plus 50. Move the 8 over. And then I move this over. But ax minus 5x is really hard to simplify because I have another mixed variable. So what I'm going to do instead is factor out the x. So x is going to be a minus 5 is equal to 58. Oops, I don't know why I put random. Okay, and all I really did there was, see how this piece had an x and this piece had an x? I pulled it out of there and I undistributed it or factored it out. Now this is really saying x multiplied by the quantity a minus 5 is equal to 58. So to find out what x is, I'm just going to divide by a minus 5, the entire quantity. So now I'm going to say x is 58 divided by the quantity a minus 5, so long that a does not equal 5. So I have to have this little restriction going on here. And the reason we wouldn't want a to be 5 is then I'd have 58 divided by 0, and when we divide by 0, the universe implodes. So take a minute, pause the video, and try number 3 independently. Now that you've tried it independently, check with a neighbor. See if you got the same answer. Okay. The next thing to talk about is interval notation. When we have something written in interval notation, it's a way of describing a set of values from something to something. So normally, for an inequality, you would see like 0 is less than or equal to x is less than or equal to 20. And that's referring to every number, including 0 and 20, and all of the numbers in between. And it's talking all of the integers, but all of the fractional pieces as well. So if I was going to graph it on a number line, I'd have 0, and then I'd have 20. I'd have closed circles. I hover mine above. You might have yours actually on the number line. And then we would have a line in between them. Well, when we write something in interval notation, this closed dot, or the fact that we're including this value, makes it a square bracket. And the fact that we're going to include 20 and another closed dot here is going to close that bracket, a closed bracket there. If I wanted it to be simply from 0 to 20, but not including them, I would have rounded brackets. This can get a little confusing in algebra because it could also look like the coordinate point 0, 20 instead of the interval of 0 to 20. Okay, so that's something we're going to have to keep track of. Because there's no spot on the number line that's like, hey, there's infinity, we always do a rounded bracket on infinity. So for example, if I had from 4 closed in forever that way. If I wanted to write that in interval notation, well, I have a closed circle, so I want to include 4. And it's going to go on forever that direction, so it's going to go to infinity. Infinity always has a rounded bracket. Similarly, let's try this interval. Let's do so here I have 2 intervals. So I'm going from negative infinity to negative 3. Since this is an open circle, it's not including the 3, so strictly less than negative 3. And then my other interval, I'm going to start at negative 2 with a bracket on it because it's including it. And it's going to 0, another bracket. Now, since this is set up as 2 intervals, because there are 2 pieces, right? I have this green piece, and then I also have this blue piece right here. Because I have it set up as those 2, we're going to put a little U in between them, and that represents the union of those 2 sets. So, solve the inequality algebraically, graph your solution, and write your solution in interval notation. So the graph is graphing on a number line. And our interval notation is what we just took a look at. So the first thing I'm going to do is distribute. So I have 2 minus r less than negative 2r minus 6 minus 4. Combine some like terms. Move that over. Add the 2r. So I have negative 6r on the left-hand side and negative 12 on the other side. Divide by a negative 6. Whenever you divide an inequality by a negative, we reverse the inequality sign. So we're looking at strictly greater than 2. Strictly greater means not or equal to. So open circle and greater than those numbers on that side. And if I'm going to write in interval notation, I'm going to have a parenthesis because it's an open circle from 2 to infinity. Okay. So take a minute, pause the video, and try number 6 and number 7. Do you do both of those problems? All right, now I'm going to take a look at number 8. So number 8, I have it what's called a compound inequality. It's a compound because there's different things going on. I have that I'm greater than one side and less than another side. So I'm going to start by adding 12. I'm going to add 12 to all 3 sides of this compound inequality. 7, 10, 14. I'm going to divide by negative 7. Again, because I'm dividing by a negative, I reverse the inequality sign. And so I always like to go from least to greatest. It looks weird to me to do it the other way, so I just flipped it around. And now we're going to right. So I'll have 2, and I'll have 3. I'm going to open circle on 2, close circle on 3, and all of the values in between. So my interval is going to look like 2 to 3 with a bracket on this one. This one's a parenthesis. Let me just make it 1. There we go. All right, take a minute and try problem 9 and try problem 10. We'll pick up with that one in a moment because that one's kind of interesting. So number 10 is a little tricky. It's a little spicier than the others. So let's try the same strategy, even though I've now given the hint that it's probably not going to work. So if I try to add 14 to all 3 sides, of negative 12b in the middle, and 28 minus 5b, and 4b plus 2. Now the problem here is this 4b and negative 5b. And again, I'm going to do this incorrectly for a moment. I try to move that 5b off of this. I had 5b, but then I have b on that side. So you end up with 9b is 32. 7. And then when you try and move it this way, it just kind of ping-pongs back to the other side. So overall, do we agree that this is not an effective strategy? So it's not working. All right, so what we're going to do instead, so I'm actually going to split into 2 inequalities. And I could do this from the first step, or I can do it from this step. I'm just going to kind of split into a blue inequality, and hopefully actually change the color. There we go. Negative, and a green inequality. And I'm just going to remember that in between them, it is an and. Okay, so I'm going to want where both of these overlap. So solve each of these. 32 is less than or equal to negative 16b divided by negative 16. We have negative 2 is greater than or equal to. So this is saying b is less than or equal to negative 2. Now this one, this over, we add our 5b. Negative 7b is 8. 7. 8 is greater than or equal to negative 4. Okay? So we're looking at the values that are greater than negative 4. You can see that b is greater than negative 4 here, and less than negative 2. Which is really just here, here. Close circle on both, and a